Hey, space cadets, ever wondered why planets are all bumpy round balls? And why they're not, giant space cubes? Buckle up because we're blasting off to find out. We're going to dive into the world of gravity, the invisible force that shapes our universe. Imagine you're floating in space, surrounded by a cloud of gas and dust. This cloud is a baby planet in its early stages. The gas and dust might be all over the place, but something incredible starts to happen. Gravity, an invisible force that exists everywhere in the universe, begins to pull this gas and dust together. Think of gravity as an invisible magnet, pulling everything towards the center. But here's the coolest part. Gravity doesn't just pull in one direction, it pulls equally from all directions. Imagine a bike wheel. The spokes of the wheel all connect at the center, right? That's exactly how gravity works. It pulls everything towards the center from all directions, just like the spokes on a bike wheel. So as gravity pulls our cloud of gas and dust together, it starts to form a shape. But why a sphere and not a cube or a pyramid or any other shape? Well, that's because the sphere is the most efficient shape that gravity can form. When gravity pulls equally from all directions, it forms a sphere because a sphere has the smallest surface area for a given volume. In other words, a sphere is the tightest shape that gravity can pack all that gas and dust into. That's why planets are round. But what about a square planet? Well, if you tried to form a square planet, gravity would start pulling in the corners, trying to make it round. That's because a sphere is the tightest shape that gravity can pack all that gas and dust into. So there you have it, space cadets. Gravity acts like an invisible magnet, pulling all that dusty stuff together, but the coolest part, it pulls equally in all directions. And that's why planets are round and not square or any other shape. Stay tuned for our next cosmic adventure. Now picture a square planet. Imagine all that pulling from gravity. The corners would get squished in first, right? That's because a square, or any shape with corners for that matter, isn't the ideal shape for gravity's tug of war. Let's think about it. If you have a squishy ball in a cube and you apply pressure all over, what happens? The squishy ball retains its shape, while the cube, well, it doesn't fare so well. The corners start to crumble under the pressure. That's what gravity does. It applies pressure from all directions, pulling everything towards the center. A sphere is like the star athlete of shapes. When it comes to dealing with this kind of pressure, it's perfectly balanced. No matter how you squeeze it, push it, pull it, it stays mostly round. But wait, there's more. Just like a spinning top, planets spin too. And that spin can cause them to bulge at the middle. Picture a pizza maker tossing a round pizza dough in the air. As the dough spins, it flattens out a bit in the middle, right? That's exactly what happens to our spinning planets. The spin tries to push things away from the center to fight against gravity's pull. But gravity, being the undefeated champion, always wins this fight. So what we end up with is a mostly round planet with a little bit of a bulge at the middle. So the next time you gaze up at the night sky, remember this. The reason we don't see square planets or triangle planets or star-shaped planets is all thanks to gravity's incredible pulling power. It's the master sculptor of the universe, shaping everything into spheres. And that's why our planetary pal here is a bit of a chubby chaser. But don't worry, we love them just the way they are. Planets spin too, and that spin can make them a little bulgy around the middle like a round pizza dough that's been tossed in the air. Let's make our own mini planet. We'll start with a bit of Play-Doh. This squishy stuff is going to stand in for the gassy, dusty material that forms a planet. Now, if we tried to shape this Play-Doh into a cube, it just wouldn't hold together. That's because, like gravity, our hands are applying pressure from all sides and the corners just can't stand up to it. But what happens if we roll the Play-Doh into a ball? The pressure is evenly distributed all around, giving us a nice round shape. This is just like what gravity does to a real planet. And here's the amazing part. No matter how much we squeeze or poke this ball, it will always try to return to that perfect round shape. That's the power of gravity at work, but we're not done yet. Planets don't just sit still in space, they spin. And that spin can make them a little bit, well, squishy. Let's take a piece of string and spin our Play-Doh planet around like a yo-yo. Do you see how it starts to flatten a bit, especially around the middle? That's because the spinning force is trying to push the Play-Doh outwards. But just like in a real planet, gravity is stronger and pulls it back in, keeping it mostly round. Now, our Play-Doh planet is a bit more squishy than a real planet would be, but the principle is the same. Gravity pulls everything inwards to create a round shape, while the spin creates a slight bulge around the middle. So there you have it, the secret to why planets are round and not square. It's all about the push and pull of forces in space. See how it flattens a bit? That's the spin trying to fight gravity. But in real planets, gravity wins, making them mostly round with a little spin-induced squish. This amazing gravity game isn't just for our solar system. All around the cosmos, from the gas giants in distant galaxies to the rocky exoplanets next door, gravity is shaping worlds into spheres. We've discovered thousands of these celestial bodies, and they're mostly round, so whether you're gazing at a snapshot of Saturn or an artist's rendition of a far-off exoplanet, remember this. It's round because of gravity's amazing pulling power. That's it for this cosmic adventure. We've had a blast exploring the gravity game and the spherical showdown. We hope you enjoyed this journey as much as we did. If you've got a thirst for more space mysteries, drop us a comment with your suggestions for our next mission. Remember, every like and subscribe fuels our spaceship for more incredible interstellar journeys. And don't forget to hit that notification bell so you never miss a mission.